So, my theme is local artificial intelligence models. Everyone's heard of classical artificial intelligence that isn't local, that is server-based, that needs large computers, large supercomputers managed by different companies, but a small percentage of people has heard of models that are completely local and can be run on your computer or phone. The most basic generation model is an image generation model. These models are specifically made to turn noise, which is visual noise, not audio noise or anything like that. It's just pixels of different colors, and it denoises them into a cohesive picture according to a prompt. The prompt is made by the user and goes through something we call a tokenizer. A tokenizer turns these words into something we call tokens. That's what artificial intelligence runs on. Tokens, you can imagine them like words assigned to a point in a mathematical space. The mathematical space can go in any dimension, it can have many dimensions, but the words are made into points. The points are assigned positions according to their meaning. For example, if we take the words love and like, they'll be near each other in the mathematical system. So it's completely meaning-based. And these words are not understood by the model. They are only used for tokenizing and generation itself. It has a training data set that can take in many images and turn them into noise, and then tries to learn how to turn that noise back into a cohesive image. All we need is a data set of like 10 images and a specific word assigned to them, and we can train a model to understand what an object is. The most popular image models are Stable Diffusion XL, Stable Diffusion 1.5, and Flux, which is the most modern artificial intelligence model that can run on your PC. Well, you may be asking, how expensive are these things on the GPU or other components? Well, the larger models, like SDXL, can take up to 8 gigabytes of VRAM. They need much more to be faster, but 8 gigabytes is the minimum. And the modern models can even take up to 24. But that doesn't mean you can't use them on your phone. There are specific models, for example, different merges of Stable Diffusion, that can be run even on your phone or offloaded to your CPU, which phones are good at. Next, we have the software we can use for these image generation models. The most popular ones are Automatic 1111, SDForge, and ComfyUI. Automatic 1111 was the first of these softwares and was made for ease of use and for beginners. It's a really easy to understand UI that allows the user to choose the model they want and just give in a prompt and it will generate, and it's really direct. But then we have things like ComfyUI. ComfyUI is for advanced users. They can connect different nodes in a flow-like diagram. This diagram is really a diagram of execution, so we can take many different nodes. Let's take, for example, a node of an input, the image. We can connect it to a tokenizer, and then we can connect it to a denoiser, output node, and things like that. that, and we can customize the process in which the generation takes form. We can even connect it to a language model, so it generates the prompts for us. Then, as I already mentioned, we have local language models. These are text generation models that are based mostly on these different models by companies. So we have Mr. AI, Llama, Wizard LM, and their merges and quantizations. I'll get to what that means after explaining the basic models. So text generation is really explained by the title. You can just put in a prompt and the model will try to talk to you in a similar system to the diffusion models. You can put in a prompt, it will tokenize it, and it will output based on the input for the most probable output. These models have their advantages and disadvantages. For example, local models are mostly uncensored and can be run on your phone even when offline, but they'll never reach the power and intelligence and creativity that, for example, ChatGPT has. But they are completely uncensored and are not controlled by a company and are completely open source. So you can mess around with their data set and tune them to your liking. So I mentioned merges. What are merges? Well, there are hundreds of base models, and we can merge these models between each other. You like the creativity of this model and the words this model uses, you can just combine them. There are specific softwares that can do this process because, of course, most AI models are just pure maths, so there can be operations to merge them. And quantizations. Well, base models are extremely expensive on the GPU. Most consumers won't be able to run a base model. So there exists a specific category we call quantizations. You can imagine them as rounding up and down numbers to get rid of decimal points. So that makes the models smaller, but less efficient. But smaller means they're able to fit in the GPU, so you don't need as much VRAM. So you can exchange creativity and intelligence for different performances on GPUs. And then we have software for text generation. There are many different softwares, but these are the most popular ones. First we have Cobalt CPP, which is meant for beginners, because it's both a front end and a back end. What that means is that you don't need to download two softwares and connect them together to make it work. You only need the software itself and the model you download it, and it just works. But then we have backends. Those are Llama and Llama CPP. Those are pure console type applications. You can only interact with them when you have special software meant for that use, or if you like using the command interface on your PC, which is really not recommended. But you can customize them even more because you can change the UI to your liking. Then we have Ooga Booga Text Gen that was one of the first softwares meant for this use. It's not really that used in the present, but it's still great for beginners. Also, I forgot to mention, all of these softwares have different settings you can tweak. You can, for example, these are really complex parameters, but you can, for example, imagine all these numbers as a graph. You can put them on a line and then work with these probabilities of these words. So you can, for example, take the parameter top p and disable the highest part of probabilities. That increases the creativity because the most used word will be completely disabled. The model won't use these uncreative words. Then we have sensory models. These are meant for connecting to the models mentioned previously. So we have LAVA. That's a vision and image comprehension model. You can take it and put it in ComfyUI or Cobalt CPP, whatever you choose. And it takes in images. You can, for example, take an image of a dog from your computer, put it in, and it will tell the model you're speaking with, yes, that's a dog. The user is sending an image of a brown dog. And the model will exactly know what you sent. Then we have Bark. That's a voice generation model which allows the text models to speak. It synthesizes a voice. You can even train a voice based on your own data. And it allows the model to speak out everything it's writing. And then we have RVC, which is real-time voice generation, and that takes in training data and converts it to real-time voices. It works in real time, opposed to Bark, which takes a few seconds to process what the input is. And then we have unusual models. So these are less known, but they're still interesting. We have Moshi1, which is a model meant for creating videos. We can plug it in ComfyUI, and it allows us to generate entire videos. Do note that this process is extremely expensive. Even the most modern consumer cards won't be able to run this smoothly. But if you have some of the most modern cards made for this use, for example, the H100 graphics card, you can run it and generate your own videos on your own computer. Then we have Oasis, which is also open source and allows to generate different games, only based on data. It doesn't make the code for the games. It's only creating connections in the neural network and displays what it thinks it should happen when you put in an input. I'll get to that later. And then we have TrypoSR, that's for 3D models. That could be useful for modeling and different design stuff because it takes in a prompt just as an image model, but can turn that prompt not into an image, but a 3D model. And then we have Music Gen, which explains itself by the title, that just takes in the input. You can describe different genres of music and even put in your own lyrics, or just let the lyrics generate themselves, and it will generate a music video or just an audio file based on your description. Then we have Oasis. I already mentioned it, and it creates games completely in its network. You need a lot, by that I mean extreme amounts, thousands of hours of data. But when you put in different videos and descriptions, what the videos are supposed to show and the inputs the user was giving, it can try to replicate the game that was in the video. The most popular example is the popular game Minecraft that had thousands of hours of video put into the model, and the model just replicated it. It is based completely on the inputs. So it saw that the user that was making the video for the training data pressed left click on a grass block, and it started mining, because that's what the video would do. So it just imagines what would happen and doesn't create the code. The only disadvantage is, two disadvantages are that it has a 3-second memory. The first thing, 3-second memory, that's really not enough for maintaining context. So if you look, for example, on some grassy hills and slowly turn to the other side, it will forget what was there. So when you turn back, there won't be hills, there will be an ocean or something. So the environment shifts constantly because of this limitation. And the second thing, the resolution is extremely low, so that it can run on lower-end computers. And that's all from me. These are the sources. Thank you for listening.